In this video, we're going to be covering notes from section 2.4. Our key today, the learning target, is to use relationships between slopes of parallel lines and perpendicular lines. Let's just jump right into Theorem 213. Two non-vertical lines are parallel if and only if their slopes are equal. Now, please note this is an if and only if. So if the lines are parallel, then the slopes are equal. If the slopes of two lines are equal, then the lines are parallel. And any two vertical lines are parallel. The reason we have this, remember, a vertical line has an undefined slope. And so we wouldn't say their slopes are equal, but any two vertical lines are parallel. So let's look at these examples. Are lines 1 and 2 parallel? So step 1, find the slope of each line. So what we do is we can find the slope triangle or choose 2 points. So line 1 goes over 1, down 3. So that's -3 over 1. That gives us the slope of -3. And line 2, if I go right 2 and down 7 is -7/2. So these slopes are not the same. So we compare the slopes. We say, hey, these are not the same, so they are not parallel. Now, another practice. This is a common question. Write an equation for the line that is parallel to this line that contains this point. This is why we practiced in the previous section of notes. So if it's parallel, that means its slope has to be -3, and it goes through the point -1/8. So I'm going to use the y minus y1 equals m times x minus x1 formula. We'll plug those values in. So y minus 8 from the point equals -3 times x plus 1. So y minus 8 equals -3 x minus 3. Add 8 to both sides. We'll do that, and rewrite. So y equals -3x plus 5. So this equation is parallel to this one, and it has that point. Theorem 214. Two non-vertical lines are perpendicular if and only if the product of the slopes is -1. Okay, I'll show you what that means. We'll do some practice in just a second. But first, a vertical line, I guess I've got lines later, a vertical and a horizontal lines are perpendicular to each other. So, product of the slopes is 1. This is when that happens. If I have some number over another number, and I multiply by the reciprocal, and one of these is negative. Okay, so often what I will say is that these slopes are negative reciprocals of each other. So 2/3, the negative reciprocal would be -3/2. If I multiplied those together, I would get -1. If I had a slope of 5, the perpendicular slope, or the negative reciprocal, would be -1/5. So are the two lines with the equations y equals 1/2 x plus 2 and y equals negative 2x plus 13 perpendicular? So we just look at their slopes. 1/2 negative 2. If I multiply these two together, I will get negative 1. And if we write that over 1, we can see clearly that that is a negative reciprocal. Now let's write the equation of the line perpendicular to this line that contains the point 15, negative 4. So the slope of this line is 1/5. So my perpendicular slope needs to be a negative reciprocal. So I'm going to write negative 5. That's the slope of the line that I am looking for, this perpendicular line. So now I will use our formula again, y minus y1. So subtract negative 4 becomes a plus 4 equals negative 5 times x minus x1. So I'll distribute that negative 5, subtract 4 from both sides, y equals negative 5x plus 71. And that's the equation that's perpendicular to that line that contains that point. And that is how we use the relationships of slopes to determine if lines are parallel or perpendicular. Thank you for watching.